Here we have a data set where we have the BMI, or body mass index. It's a measure of how much extra weight you have on your body, and the age. And this is for men in a 161 kilometer trail ultra marathon. So a huge marathon that's going to take a lot of physical exertion. So we kind of expect these guys to not have a lot of extra weight on their bodies. But here we are comparing the BMI and the ages of all these people that were running, or all these men that were running the marathon. And you can see different age groups here and different body mass indexes. And when we look at a scatter plot of this data, we see along the bottom the different body mass indices that you can have. And it looks like our smallest was 21, and there's a 21.6, and our largest 25, almost 26, it looks like, and we have all the way up to almost 26. So our BMIs are showing the range of the BMIs from our table. And then the ages, it looks like 34 might be the youngest, 28 is the youngest, up to, it looks like 60 is the oldest. So 28, so right in here around 30, all the way up to 60. And you can see all that data is in between those two ages. So it looks like our scatter plot is doing a pretty good job. And if I were to make a line, I think it would go somewhere about here, because that's pretty close to most of my data points. Now, this line is just an estimate that I'm making, but we can use technology to find the exact line, which we'll do in a little bit. But the first thing we want to do is check our technology and see if these two, body mass index and age, are correlated, and how strongly correlated they are. So to do that, we'll use the calculator. And we want to clear out our old data first. And it says always do that, so let's always do that. So we'll do second data, and then slide over just like we did before, and do a clear data, and then second data again. And this time, before we did when we were trying to find mean and standard deviation for a single data set, we used the 1var. But here, when we have two variables that we're comparing, one in the x direction and one in the y direction, we're going to use that 2var. And that's the big difference here. And then we push enter, and then I'll push data to get started. So what I've done this step here, press second data and then 2var and press enter, and then I press data, and now it says x sub 1, and I want to enter the first data value. So I have my table here, and I want to see if I can scroll up just a hair. There, I can see the whole data table and my whole set of instructions. So x sub 1 is going to be the number on the left, which is at 23.4. So 23.4, and then you use down arrow. This gives you the y right away. So in the y, I want to put in the 53, because that's the age that goes with the body mass index that I just put in. Once I do that, I really want to check off that I took care of that row so that I don't forget where I am. Push down arrow again. It wants x sub 2. That's the 25.7. Go down 1 and type in the age that goes with it, and that's the 47. And then mark that off on your paper and continue on until you've entered in all of your data points. Now I've entered my last data point, and I want to count and make sure how many data points I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I can see that my calculator is showing that I just entered the 12th value, and it's a y. And so I have a pretty good feeling that I've entered all of my data. So that gives me a quick double check. I can also use my up arrow button to go back through every one of them if I wanted to double check each value. But I don't have to. I can double check and see that I entered 12 and then assume I did them correctly, or I can go back through and check The thing I'm looking for here is to see if I have any that have like 3 digits, because sometimes I have that fat finger syndrome where I push 2 buttons at once, and then it might put, instead of put 60, it might put 601 or 600 or 603. So I'm looking for that kind of error right now. And everything looks good. So the next step here, this was add all of your values and do down arrow in between each, and then press stat var, just like we did before, and it does calc, and then we're going to go left 1. So using that left arrow, go left 1, and there's y prime, x prime, r. There's the r, that's what I wanted. So scroll to the left 3 times and you get to r. So my r for this data set is 0.5763. And if I look back at my chart, 0.57, it was a positive. 0.57 is going to be a moderate positive correlation. So I can say there's a moderate positive correlation between BMI and age in the ultra marathoners. So if it was in people who weren't doing an ultra marathon but just regular people, I think there might be a stronger positive correlation, but it's just because these guys are so fit that even if they're older, they still have a little bit of extra weight on them, but not nearly as much as the average population. That's my guess. So the other thing that we can look at is as BMI increases, and this is from our graph again, as the BMI gets bigger, so does the age. So as the BMI increases, so does the age of these ultramarathoners.